Okay, let's go ahead and get started. Good afternoon, everyone. We're going to need a little bit more enthusiasm than that. So, good afternoon, everyone. Excellent, excellent. Well, welcome. I'm super excited to be here kicking off the exchange track here at TechEd Europe 2013. How many of you have been to TechEd Europe before? All right, fantastic. How many of you have deployed Exchange 2013? All right, excellent. How many of you are on 2010? 2007? Any 2003 left in the room? Anyone earlier than 2003? You'll have to step out. No? Okay. All right. Well, welcome. It's a pleasure to have you all here. For those of you who don't know me, my name is Scott Schnall. I'm a technical writer on the Exchange team. Among other things, I write the product documentation for things like managed availability and high availability and site resilience and disaster recovery and a few other areas as well. And so I'm really excited to be talking about managed availability, which, for those of you who've already deployed Exchange 2013, maybe you've had a chance to experience. And for those of you who haven't deployed Exchange 2013, this may be new information for you. So for those of you who have deployed 2013, how many of you are familiar with managed availability? Just a couple hands. That's not much of a surprise to me because managed availability is brand new technology that we introduced in Exchange 2013 for the first time. And today we're going to walk through it quite in a lot of detail. And in addition to this session, there's also the Exchange Tips and Tricks session on Thursday where I'm going to have some tips and tricks around managed availability and figuring out what it's doing on your system as well. So hopefully you'll join me for that one. In terms of the session objectives, this is really just to sort of level set everyone's knowledge on the basics of managed availability, what it is, why it came about, why we have it in the product, what kinds of things it does, how it works, how administrators can look at what it's doing, how administrators can control what it's doing, and so forth. So even if you are using Exchange 2013 today and you have no idea what managed availability is, by the time this session's over, you're going to have a very good handle on it and hopefully feel a lot more comfortable having Exchange doing some new and different things that it hasn't done before. So what's really brought about the major change and why we introduced managed availability, there were two primary reasons. One is product related, the other is service related. Let's talk about the product related one first. As many of you probably know, we've made significant architectural changes to Exchange 2013. It is really not like any other version of Exchange that we've had. Yes, a lot of the nomenclature is the same. We still have things like the information store, for example, but it's not the same information store as what we had before. There's a lot of things that, even though they have the same names, they are very new and different in 2013. One of the more significant changes that we made was the overall server role architecture and the client connectivity model. So it used to be in Exchange 2010 and 2007, clients would connect to CAS, and then CAS would, on behalf of the client, communicate via RPC to that user's mailbox server, and then the data would go to CAS. CAS would render the data and deliver it to the client. The new CAS that we have now in 2013 is really nothing more than what you would consider a smart protocol proxy. Doesn't have any data storage, doesn't do any data rendering, nothing like that at all. It's really just a thin, lightweight protocol proxy. And so what that means is that all of the activity that is really related and germane to a user's mailbox access, that's all happening on the mailbox server now. And in fact, it will always be the server that hosts the active copy of that user's database, which is where that activity will take place. And as a result of that architectural change, that also made us make changes the way we do monitoring of Exchange. Now, typically and historically, when we talk about monitoring Exchange, we're talking about monitoring it via some external means. We still have the ability for you to do that, but that's not the way we do monitoring really in Exchange anymore. Now the monitoring, when we talk about it, it's all internal. It's built into Exchange. Not just the monitoring, but also the recovery actions and the notification components for escalation purposes as well. That monitoring is called managed availability. So really, it's nothing more than high availability that has been extended beyond the database, beyond the content index, to the rest of the services and components and protocols that make up Exchange. So this was one key architectural change that sort of drove a lot of the changes we made in introducing managed availability. Again, the key change is that all activity related to a user's mailbox is happening on that mailbox server that hosts the active copy. CAS is still there, but it's a lightweight protocol proxy at this point. Now, the majority of the changes really came out of running Exchange 2010 in the service, and when I say service, I mean services like Live at EDU, Exchange Online, Office 365, and so forth. Our experience in running Exchange 2010 in those large-scale environments have both showed us and taught us things that we didn't know before. We never knew because we never achieved that scale before. Right now in Office 365, we've got just over 160 million mailboxes that are deployed and active at any given time. And so the scale at which we've deployed, I mean, we're talking massive amounts of data, large numbers of servers, massive numbers of client connections. And in the old paradigm, of course, in terms of monitoring, a lot of monitoring that needed to be done. So if you look at managed availability in Exchange 2023, there's three key principles that came out of it. One is that it's cloud trained, and I'll explain what I mean by that in a minute. It's basically taking things that we learned in the service and applying it to on-premises, but we'll go a little deeper than that. It's also user-focused, and this is not just a technology change, but it's also a mindset change, and hopefully one that you will walk away with at the end of this session as well. And then the last area is it's recovery-oriented, but when we talk about recovery-oriented, we're talking about recovering that user's experience so it's back the way that they expect it. So in other words, imagine if you had a bunch of digital administrators that were watching at any given time hundreds of different elements of the system. And if something goes wrong with one of those elements, one of those digital administrators will go and try to fix it using a pre-programmed sequence of fix-it steps. And if those steps don't solve the problem, this digital administrator has the ability to log an event in the event log and notify human administrator that there's a more serious problem that needs their attention. That is basically what managed availability does and how it works. So when we talk about cloud train, so obviously services like Exchange Online and Live at EDU, they've been around for some time. Since late 2006, early 2007, so literally almost 7 years now, the Exchange team itself has been running Exchange in a service-oriented topology, again, Office 365, and we've gained a lot of knowledge and insight. For one thing, scale magnifies everything. The scale at which we operate is significantly larger than any other Exchange installation on the planet. And so at the scale that we operate with all the servers and hard drives and whatnot, we see things that the typical Exchange infrastructure is not going to see, even though we're running the same code, even though we're using the same best practices that we tell you to do in our documentation. The fact that we're running at scale makes things quite a bit different for us. So one of the big differences is we're learning a lot as we go. And these learnings, where applicable and relevant, we will take them and somehow integrate them into the on-premises product. And that is, in fact, where managed availability came from. It was originally called active monitoring, and it was introduced in Office 365 when it was running the Exchange 2010 version of that service. And in running that version, we realized that the monitoring solution we were using didn't scale the way we needed it to. And as a result of it not being able to scale, we decided we needed to come up with a new approach, and that's how managed availability was created, and that's how it came into the on-premises product. So it's the scale and the optics and the high availability, particularly around the user experience, that is what is most key to us. That's going to be a different approach than perhaps most of you are used to taking. How many of you are the actual administrators of your Exchange servers? Okay, so for years, you probably know that you're doing things like keeping tabs on services, and you're collecting performance data, maybe externalizing event logs, and watching all these widgets and moving parts just to make sure everything is okay. If a service crashes, you go and restart it right away, and life is good. But that old approach, this watching the components and the widgets and whatnot, that really doesn't work well at scale. It may be one thing to have a service crash and then you go and fix it, but when that's happening at scale, it's not really a viable option to send an administrator out to go and fix those things. We call it administrator and operator in the service. Anytime we need to dispatch an operator to do something, that costs us money. And anytime that happens, that means we're not able to provide you the service that we want to in an economical manner. We need to keep our costs low so that your costs to use the service are also low. So any opportunities that we have to introduce automation, reduce complexity, allow the system to self-heal or self-recovery, we will investigate those and leverage them where possible. Managed availability is one of those areas that we've done that. If you come to the high availability session in this room later on this afternoon at 5 p.m., we'll also talk about another similar feature called auto reseed, which was born out of the same reasoning, if you will. Now, the learnings go back into the product. Now, not everything we learn is germane to an on-premises product. Some of the things that we learn are really there for our own benefit because of the scale at which we operate. But there is a large knowledge set and a large amount of experience that we've gained over operating the service over these many years that has made its way into the managed availability stack in Exchange 2013. So what do we mean by user-focused? Well, again, this is a different mindset. It's not the mindset of, is the service running? Are the performance counters within the threshold? Are there any errors in the event log? To a large degree, you don't really necessarily need to care about that stuff anymore. You really want to think about just the 3 pivot points, or what we call customer touch points for managed availability. So obviously, one of them is availability itself. Can I access the service? So it's kind of like going to the store. If I get up and I walk to the mall and I go to the store, is the store open or not? Can I get in or not? The next one is latency. How's the experience? Is it super snappy? Is it what I would expect? Or is it a poor, a slow experience where things are just taking forever, even simple operations like opening or responding to email? And then the last touch point is errors. Am I able to accomplish what I want, or am I encountering some error message that is unwanted or unexpected? These are really the 3 touch points that are most relevant and most important when you're running a service like Office 365. The new approach as an on-premises administrator, for those of you that are, the new approach is to get you to operate your on-premises infrastructure as if it were a miniature version of Office 365. Because in reality, if you're the Exchange administrator and you're responsible providing messaging services, for example, again, the end users and your managers, they don't care about what the state of services are. They're only going to care about these 3 touch points. Could I get in? Could I do what I wanted in a relatively speedy amount of time? And did I access any errors? That's really what you should be going for, is preserving that ideal experience. And that's what we're going for by focusing on the user experience inside managed availability. So let me just show you a couple real basic things here. So I'm going to switch over to my demo system, and this is Exchange running in a Hyper-V environment. I've got 1 directory server and 2 Exchange servers, and I'm actually remoted into one of my Exchange servers, so you won't see the rest of the topology right now. But I do want to highlight a couple things about the way managed availability works. And I realize it's small to see, but I will be using Zoom It to zoom in and out on a few things. So the first thing I want to show you here is the Crimson Channel event log. How many of you are familiar with that term, Crimson Channel event log? Okay, it's not necessarily an Exchange term, but we use it in Exchange all the time. It's actually, this was developed in Windows 2008. And it's called the Crimson Channel simply because it's meant for applications to log information that can be consumed by that same application. And so Exchange 2013 and Exchange 2010, for that matter, use the Crimson Channel extensively within Windows for all of its operations. And in fact, the Crimson Channel is a necessary component for Exchange to operate. If the Crimson Channel becomes unavailable for Exchange for a period of 30 seconds or more, Exchange will actually try to correct the problem by forcibly rebooting that box. And again, I'll talk about that kind of stuff in the high availability session. But I wanted to point out that the Crimson Channel is really nothing more than the event log area that you see here. So you see at the top it says application and services logs, and then down below that you see hardware events and Internet Explorer. Well, below that you see a folder called Microsoft, and then below that there's one called Exchange, and below that there's one called Active Monitoring. Now, the Active Monitoring Crimson channel is one of the primary event logs that you really want to familiarize yourself with. There's one primary reason for that, and we haven't talked about it yet, but there are three primary components to Active Manager, managed availability, excuse me. One is the probe, the other is the monitor, and the other is the responder. We're going to talk about all those things in a bit, but this is where, in this area of the event log right here, this is where on startup, we log everything about all those three elements. So every single probe that we have gets logged inside this Crimson channel. Every single monitor, as it becomes initialized, gets logged here. Every single responder, as it gets initialized, gets logged here as well. So if you're curious about what one of these things is doing and what its retry interval or what's the maximum number of tries it might do, you can go into one of these logs and find that out. So, for example, and by the way, there will be a little bit of a delay in the zooming because the Zoomit is actually running on the remote system. So you're seeing Zoomit operate through a remote desktop right now. So if you look over here, if I just pull up probe definition, for example, and there's a bunch of events in here, and these are all going to be informational events. I'm just going to pick one at random here. And when you look at these events, don't just look at the general pane. What you really want to do is you want to go to Details, and you want to turn on the XML view. And this will populate in a second here. And give it a second to zoom in here. So I just randomly picked one of the probes here. Okay, so in this case, the probe I happen to pick here is one of the search probes. So it's search.probes.search word breaker loading probe. Okay, so what this is doing, this is a probe that happens to be checking the new search engine in Exchange 2013. It's called Search Foundation. And it's making sure that the component within that search engine is properly indexing the words by, in this case, word breaking them where they need to be. This is one of hundreds of probes that are doing things and evaluating different aspects of Exchange every second. Literally every second, hundreds of things are being evaluated. This is just one thing. As we drill through this, I can scroll through this and move this down. You can see some of the information about it. Obviously, here it is in search. You can see when it was initialized. You can see its timeout value. Here's max retry attempts. We can see it's 3. So this particular probe will try 3 times to succeed before it goes into an unhealthy state and then trigger some recovery mechanism, which I'll show you in a moment. And again, this is going to be the key area. We don't have all of the probes and monitors and responders documented on TechNet. So if you're interested in a particular one, it's the event log where you're going to go and find those kinds of things. So that was the probes. There's also the monitors and responders in here. But just as a quick example, I just want to show you a couple things here. So this is just a service control manager, nothing you haven't seen before. And I do have one service that I've selected here. It's the Microsoft Exchange Replication Service. This service is required to be running on all mailbox servers, whether they're members of a DAG or not, because the replication service is where Active Manager lives, and it's Active Manager that decides whether or not a database will mount. So whether this mailbox server isn't a DAG or not, if this service is not running, no one is going to be able to get into their mailboxes. Now, obviously, if the service were to crash unexpectedly, the Service Control Manager itself would recognize it and restart that service automatically. But what happens if an administrator just goes in and instead of the service crashing, they just click the stop button? Okay, so I'm actually stopping this service. Now, when I do that, that's going to put one of our health sets into an unhealthy state. When we look at the probes and the monitors and responders, they're all grouped by what we call health sets. So a health set is really just a collection of those items. And there's a variety of health sets. There's one for instance, the Exchange Admin Center. There's one for Active Directory, one for DNS, one for Active Sync, one for POP, one for the store, one for search, et cetera, et cetera. Basically, every single individual component in Exchange has one of those that's assigned to them. Now, in this case, the service is stopped, which means not only would replication stop, but replay is also not happening as well on this service. So I'm not going to do anything with the services. What I'm going to do here is I'm going to go to the Exchange Management Shell, and I'm going to run a couple commands. The first thing I want to do is I want to run get mailbox database copy status, because I just want to see the status of my mailbox databases on my particular service. So I'm not even going to use any parameters. I just want to see what the copy status is of the databases on this particular server right now. And once it's done interrogating them, because the service is stopped, hopefully the copy status will accurately say service down. So we'll wait for that to evaluate in a moment here. And the other thing, it's actually running side by side with managed availability right now. Managed availability is always on, and it's possible that during the time while I'm waiting for this information to appear, so you can see up here it says service down. Let me zoom in on that for you. Up at the top. So we looked at our databases on this server. EX1 is the name of the server that I'm on. You can see I've got 2 mailbox databases, and both are now in a service down state. So that's not good. That would be a condition that without managed availability, an administrator would have to go in and start that service and fix it. But let's go ahead and look at Service Control Manager a little closer here. And I'm just hitting F5 for refresh. And look at that. I don't know if you saw, but suddenly look. That service that we had stopped is now in a running state. Why is it running? Because managed availability detected that the service was stopped. It recognizes that that's kind of an important service, and it automatically started it back up for me. So how do I know it was managed availability? Well, that's back in the Crimson Channel area. Under here, under this other area, and again, I will zoom in a minute, called Managed Availability, and there's this other Crimson Channel logging called Recovery Action Results. And if my trackpad weren't so wiggly, I could click on it and zoom in. And give it a second to display those here. Okay, well, there are 2 events there. I don't know why it's not showing them. Let me refresh the event log here. There they are. Okay. So there's 2 events. One is event ID 500. And that is the event that gets logged when a responder initiates its recovery action. In this case, the responder, all it needed to do was restart the service. And then there is the other event, event 501, which gets logged when the responder successfully completes its task. Now, in this case, if I were to go into the actual event log, you can see here some of the text around this. Had it not been able to restart that service, it would have still logged event 501, but 501 would have been an error event, not an information event like you see here. So if we look in that, that's zoomed a little too far. Sorry about that. Let's zoom up just a little bit there. Okay. So you can see it says recovery action succeeded. The action was to restart the service. The service name is MS Exchange REPL, which is the short name for the replication service. And the requester is also the name of the responder. Whenever you see the word requester, that is also the name of the responder. So in this case, it's Service Health MS Exchange REPL Endpoint Restart. And yes, that's a mouthful. Some of these responders are very long named. But typically, we use names that, just at a glance, looking at the name, you should be able to tell what that was doing. Oh, great. There goes remote desktop. We'll come back to that in a minute. Okay. So what do I mean by recovery-oriented? So you saw some of the definitions. You saw the probe definitions, for example. So those probes are out there doing a couple things. First, they are mimicking a user by invoking what we call synthetic transactions. Every Exchange mailbox server, every Exchange 2013 mailbox server that you create will have what we call a health mailbox that is all automatically created for it. That's a special system mailbox that the system itself uses to pretend it's a user accessing its email. So for instance, it'll do things like try to open up that mailbox via Outlook web app, or try to send a message through that mailbox via the Outlook web app protocol, just like a user would do. So these synthetic transactions, because they are mimicking the user experience, when they run, we're able to tell internally if the user experience is good or not. And if the user experience is not good, managed availability is able to go in and take recovery action. So here's one example, and this is one of, again, hundreds and hundreds of examples of how managed availability can work. So over here on the end, in this orange square right here, this is where the client is. That's not a real client. That is the internal managed availability code pretending to be a user. And what it's going to do, just like a user would, it's got the namespace associated with it, which will point to a load balancer. So it'll go through the load balancer, through one of the CAS, it'll get authenticated, and then it will access the mailbox wherever that happens to be located. So let's just say the mailbox happens to be located on MBX1 right there. And the active database copies are there in red, and the passive database copies are there in white. So again, managed availability is mimicking the user experience. So it will, for instance, invoke what we call an OA send internally. Managed availability will open its mailbox via the OA protocol. So it'll do the same name resolution that a user would do in the organization. It'll resolve that to the load balancer. Once the load balancer hands it off to a CAS, the CAS server will authenticate that internal user. It will then look up to where the health mailbox is, and then it will render that mailbox for that user against the mailbox server. Once the mailbox has been opened by the managed availability probe, it will then go ahead and do an OA send. It will actually send a mail message to that mailbox to verify that it was received successfully. So in this case, the OA send is successful and life is good. But it's possible that maybe the OA send was not successful. If managed availability is not able to successfully complete an instance of a probe, like this OSN, for instance, then it will invoke its recovery actions. So in this case, it detected there was a failure in OA. It could not get to the mailbox. So it invokes what we call OA fast recovery. This would be a responder that's going to automatically try to recover the situation. Typically, the most common form of recovery is going to be recycling the protocol. So since this is an IIS-based protocol, that might mean stopping and restarting the application pool within IIS, or it might mean stopping and restarting the IIS service itself. Whatever is needed, managed availability is going to try to do that to fix it. Once it's fixed, managed availability will then verify that it's still healthy. And then once that's done, it will repeat that process over and over again. It will begin with the OSN process, verify that it can open up the mailbox, send a message into that mailbox, and again, if it encounters a failure, it will try to recover that by invoking OA fast recovery. Now, let's suppose, though, that maybe the problem is actually a lot worse than IIS. Maybe recycling the app worker pool or recycling IIS did not automatically fix the problem. Managed availability has the capability of doing other actions as well. So for instance, if OA is down, nobody's getting into their mailbox on this database via the OA protocol, and it's most likely no one's getting into their mailbox on that entire server via the OA protocol. So managed availability will recognize that, and it will invoke a failover, a server failover basically, of all the databases. Now, this is different from the server failover you would get from Active Manager. It's still happening perhaps in a DAG. Databases are still moving around, but it's not an Active Manager failover. An Active Manager failover would be in response to a database or a content index type of issue. Here, this is a protocol issue. And because it's a protocol issue, it's up to managed availability to fix the problem. So managed availability fixes the problem by failing over the databases to a server on which OA is known to be good. And because OA is good on that other server, everybody should get in. Now, eventually, the problem will get fixed on the original server, and it will be verified as healthy. And once it is verified as healthy, then that original server simply becomes a good target for failover again. So once managed availability failed over to server 2, when the problem is fixed, it will not fail back to server 1 because life is good on server 2. You might as well just stay there. Of course, the administrator could always go and do a switchover or rebalance the DAG if they wanted to move databases around. But at this point, when we failed over from server 1 to server 2, the problem from the user experience perspective has been fixed, and the user's back in their mailbox and life is good. And to a large extent, when you're running a messaging service, that's all you really care about. Life is good for the user. All right. So let's look a little bit more under the hood. Hopefully we can get back to our RDP session there. Yeah, must have just been intermittent. So in the last one, all we really did was just stop a critical service, and you saw how the system recognized that and automatically started it back up. But there is so much more that managed availability is able to do. There are so many different sets of sequenced steps that it is able to take. But each one of the probes and responders and monitors were basically created by the individual component teams. So in the example I showed you with the Outlook web app one, all of that work was created by the Outlook web app team. In the demo I showed you where I stopped the replication service and the system automatically restarted that, there's a health set called data protection, and the replication service is part of that health set. That was created by the replication team, by the Exchange Mailbox HA team. So every component team within Exchange has their own managed availability components that they were required to create for Exchange 2013. Okay, so here we are back in the event log. And again, just looking at this one last time, this was our service restart. You can see, for instance, the actual start time, and you can see a stop time. So you'll know how long it actually took it to restart that service there. But now I'm going to do something a little bit different here. And I'm actually going to do two things. First, I'm going to bring up a web page. And I'm going to log into the Exchange Admin Center. How many of you have never seen the Exchange 2013 Admin Center yet? All right. So this is what it looks like. This replaces the Exchange Control Panel and the Exchange Management Console that we had in Exchange 2010. So there's no more MMC. It is now just the Exchange Admin Center, which you see here, and the Exchange Management Shell, which is the PowerShell that you saw earlier. So I'm going to go over here to my servers, and I'm going to look at my databases. And again, give it a, whoops, I know I'm not on the RDP yet. 1 second. All right. So if we zoom up in here, you can see, again, that both of my databases are replicated to both servers. Both of them are now active on server EX2, so there's nothing on server EX1. We're going to change that real quick. I'm going to do a database switchover. And that's actually really super easy to do. You can see over here on the right-hand pane, when I have a database selected here, it shows me all of the database copy information. So I can see where the database is active and mounted, and I can also see the state of the passive copies. So I can see the passive one on EX1, which is the lower server, is in a healthy state. And I'm just going to go ahead and click Activate and do a quick switch over there so that I have an active database on server EX1. And then what I'm going to do is I'm going to mess with managed availability. I'm not just going to stop the replication service. I'm going to set it to disabled. Now, there is no corrective action in managed availability that says take a service whose startup state is set to disabled and turn it to automatic. So that means in order to correct the problem, managed availability is going to have to come up with a different solution to restore user service. So we'll just give this a second. There's switchover happening right now in the background, And now it's finished there. And again, you can see, if I zoom in here, now you can see it's active on server 1. OK, so now let's go back to server 1. And we can close Event Viewer. And as I said, instead of just stopping the service, I'm going to go into its startup state. And I'm going to set it to disabled, because that will prevent it from being restarted. And then I'm going to issue a stop. Now, managed availability does have retries, and it will actually try to restart that service a couple times. But eventually, that service will not be started. It's going to issue an error back to managed availability saying the service is disabled. Managed availability will still try to start it again, even in spite of that message. And when it can't restart it, then it's going to escalate its activity, in which case it's going to invoke a failover responder that takes the active databases from EX1 and fails them over to, in this case, EX2, another viable system. So we can see that happen a little bit. If we go back to here, we can just simply keep refreshing. And eventually, you'll see it will change from active. There, you can see already some of the stuff is changing. The status up here is now unknown. It's unknown because the replication service is stopped. Active Manager lives within the replication service. And so if the replication service is stopped, there's no Active Manager interface to this system. And therefore, all the status we get through the UI or through Get Mailbox Database Copy status, all that becomes unknown because we cannot make RPCs into this server anymore. So if we keep refreshing here, we'll stay in unknown. And if we just wait a little bit, it'll eventually take the corrective action, which again will be failing over that database and mounting it on EX2. Now, managed availability will try to correct things as soon as they are detected, but it doesn't run in real time. It's not watching everything every second. There's groups of things that it runs. Things get timed and staged out based on things like the retry interval, the amount of time it takes for the activity to happen, and so forth. So the fact that I've stopped and disabled this service, it might actually stay in this state for a few minutes before it's actually able to detect the problem and then correct it. So we'll keep refreshing here. Whoops, I think I refreshed the whole browser. Go back to databases. Still active on EN1 with an unknown situation, so we're just waiting for it to invoke the failover. OK, so while we're waiting for that to do, let's go ahead and we'll go back to the slides, and we'll come back and babysit or check on that in a bit. All right. Now, here are the components of managed availability. Okay, you've got the probe engine, which consists of those three blue parts, the probes, the checks, and the notify. You have the monitor state, which plugs into the responder, which we call recover. And then there's an escalation mechanism that can come off the responder, but it can also come off the monitors as well. So we're going to walk through each of these components. But the point is that managed availability is inside every single Exchange 2013 server. It's on by default. It runs by default. We don't want you to ever turn it off. Even in your lab environments, keep it on, let it do its thing. There are some adjustments that you can make, and I'll show you what those are in a bit. But you want to leave things on, and you want to let it do its thing. Now, down here we have this box, SCOM, System Center Operations Manager. And there is integration with System Center. Now, we don't use the same monitoring history that we had with System Center. In other words, System Center itself is not doing any of the actual monitoring. Rather, System Center is acting as an escalation endpoint and a viewing console for managed availability information that is sent to it from Exchange. So that is very different from how you may have used System Center in the past. But I do want to point one thing out. The way in which we escalate to an administrator to get a human involved to fix the problem, yes, it can go to System Center, but the way we do it is through event logging, which means if you have any application that collects event logs and can notify an administrator when a certain event is logged, you can use that instead of System Center. System Center does have the ability, though, to understand and display the managed availability health sets, so you will get a better experience if you use System Center, but System Center is not required for escalation because we just do it through event logging. So here are the monitoring layers. And again, these relate to those customer touch points that we talked about, that accessibility, the latency, and the errors. And some of the touch points are shallow. Some of them are very deep. And we typically break them down into two separate ones, a system level check and an end user level check. The end user ones are super, super deep. They go all the way down the stack. So here, what you're seeing is the various layers that might be associated with a store type of probe. We've got the protocol proxy up at the top in CAS, and then the protocol stack and the store on Mailbox. All three of those components have to be healthy and in a good state in order for a user to get into their mailbox, or in order for managed availability to be able to test one of these mailboxes. And the way in which we will mark these depends on the component itself. So for instance, something like Outlook Web App, we might check every 20 seconds or so to make sure it's good. But something a little lower priority, like POP or IMAP protocol, for example, we might check maybe once a minute, once every 5 minutes, and so forth. And then, of course, other critical dependencies, things like Active Directory, DNS and name resolution, other critical things like cluster-related stuff, we're checking much more frequently and much more rigorously. But it is based on a timeline. So for instance, every 5 minutes, we might do what we call a mailbox self-test. And this is, again, managed availability, pretending to be a user, using its own health mailbox to verify that it can open up that mailbox and access it via, again, the OA protocol as an example. Doing that not only verifies that the protocol proxy is good, but it also verifies the other stuff. Now, in the case of the mailbox self-test, that's really going only deep as this one layer. So you see this number 1 here that goes all the way from store to protocol. So the mailbox self-test is just testing that part of the mailbox access. Is the store up and running? Is the replication service up and running? Is search up and running? And so forth. It's a very quick and lightweight test. Are the protocols on the mailbox server functioning properly? And so forth. Then we also have the protocol self-test, which is really just looking at the protocols themselves. We don't need to test the store every single time we evaluate protocol health. We can just evaluate protocol health through a very quick web service or some other HTTP-based call. And we also have the proxy self-test, so that is going to be limited to the CAS, which is where the protocol proxies live. And then those are the system level, and the end user experience, as you might imagine, goes all the way deep. Touches everything. And that was that OS send animation that you saw before, where we're looking at the entire experience all the way from the client side through the load balancer, through CAS, all the way into the mailboxes. And we're just checking everything at that point. That happens about every 20 minutes or so. It's not going to be on the clock every 20 minutes. It's about every 20-minute intervals. It has an opportunity to run. Whereas the other ones, the system level checks, which are shallow, but they still do a good job of checking, those can happen every 5 minutes, or in the case of the proxy and protocol tests, every 20 seconds. And again, this is just one example out of, again, hundreds and hundreds and hundreds of different things that we'll check within the system. So let's talk about the probe engine. The probes are one of two things. Either they're those synthetic transactions I talked about earlier, or it's the probe collecting performance data. And we use the Microsoft Exchange Diagnostic Service to do that. We have pre-built performance data collectors that will go and collect data. And in fact, if you look in your Exchange 2013 logging folders, you'll see that we will build up quite a bit of logs. We do have a maximum limit of 5 gigabytes of performance data, but that's a lot of data in the file system. And in fact, for those of you who are wondering why our minimum free disk space requirements went up so considerably in 2013 over 2010, we only needed 30 gigabytes of free disk space in order to install Exchange. 2013, we need 300 gigabytes of free disk space in order to install Exchange. We need that because of all of the data collection that is constantly going on through managed availability. And again, if we're just collecting 5 gigabytes of performance data, you can imagine we're collecting gigabytes of other logs as well. So keep that in mind. We're doing a bunch more stuff in the file system, including having the probes collect all these performance data. So when you see these performance collection things that are at least a gigabyte in size each, don't delete them. They're super necessary for managed availability. It's responsible for collecting. It will trim them itself. You don't have to worry about that as long as you have enough free space. So the probes will get the performance data, and they'll do the synthetic transactions. The data that they collect or the results that they get from those transactions will feed into the check engine. So the check engine has a listing of all of the acceptable thresholds for each of the components, and that verifies whether or not we are above or below those thresholds. If we are within the thresholds, then the probe doesn't do anything. It just goes along its merry way. If we are above the threshold, then that will invoke the check, and the check can feed the stuff into the monitor component, which we'll talk about next. Or if we are well above the threshold, or if we are in such a state where the probe itself determines that something is really bad and we may not be able to correct it right away, then the probe itself has its own notification component. Now, the normal process for a probe is to take its data, pass it to the monitor does the evaluation, and then sends it to the responder to take corrective action if necessary. But there are some scenarios where the situation is so bad, then it doesn't matter if we send it to the monitor because we are going to have to invoke a responder. And so there is a shortcut mechanism so that the probes can use their own notification component to immediately trigger recovery or immediately escalate to an administrator to solve a problem that doesn't need to go through the monitor because on its face, we already know it's so bad. Okay, so these are the components of the probes. Then there's the monitors. The probes take their data, and assuming nothing is way out of whack where the probe needs to notify on its own, the probe then takes its collected data and it passes it to the monitors. Then the monitors query that data, and they compare it to these predefined thresholds that each component team has set, and they evaluate it against those thresholds. It's kind of similar to pattern matching, if you will. And what will happen is they'll either exceed those thresholds or they'll be within them. If they're within the thresholds, we'll just mark that down and continue on our merry way. If we exceed the thresholds, then it's up to the monitor to invoke a responder to take that corrective action. Now, the monitors have a state that's associated with them, and it basically, that state will determine the overall state of the health sets. Remember, monitors and probes and responders are grouped together in a health set. So each health set might have dozens of components in it. And let's say you have a health set that has 10 components in it. If 9 of them are healthy and 1 of them is unhealthy, then that whole health set will be considered unhealthy. So health from a monitor is driven by a health set, and it's derived by the least healthy component. So if the least healthy component is unhealthy, the entire health set is unhealthy. And then there's the responders. The responders are there to invoke some form of recovery. Again, maybe cycling an application worker pool in IIS, restarting IIS, restarting a service, failing over databases, failing over a whole server, or maybe even taking a server offline or out of rotation if the problem is super serious. So there's a variety of responders. The most common ones that you'll see that get invoked are going to be the reset app pool responder or the restart responder, which is terminating and restarting a service. Every once in a while, those responders won't be successful, and so you'll see the failover responder happen as well. And not as frequently, but every once in a while, you may see what we call our bug check responder being invoked as well. This is when the problem detected by managed availability is so bad that the way in which we've programmed managed availability to recover is to forcibly reboot or bug check that box. Basically, we terminate the win-init.exe process that causes the blue screen and triggers a server failover. And perhaps when the server comes back after that reboot, life is good. Perhaps not, but either way, we've already dealt with the problem by failing over databases to another server at that point. But it's the responders that have this built-in sequenced set of steps that they can invoke for recovery action. If the recovery action is not successful, then the responder will escalate to an administrator by logging events in the event log, basically the 501 error event that says the restart action was unsuccessful and an administrator needs to get involved. So if you think about managed availability as almost this pipeline of activity, which really is what it is, because once those services start and are instantiated, that timeline starts running, and the clock is running, and all the probes start doing their things, and all the monitors start doing their things, and if necessary, the responders get involved and so forth. So it is a time sequence set of steps. And it's largely based on these monitor states. So we have the probes over here, and they're grabbing a bunch of data, but it's really the monitor states that drive what happens with that data. So for example, the monitor states are either going to be green or they're going to be red. Green meaning they're healthy, red meaning they're unhealthy or otherwise not healthy. So as long as the monitor state is green, then managed availability really doesn't have a whole lot to do. It's really just evaluating things. But and while it's green, it will still run through its timeline of activity as well. We'll verify that things are healthy. And if anything turns red, meaning it's not unhealthy, then it will invoke the timer that triggers off the responder actions. So for instance, if we say at T1, at the first timed interval, which is when the clock starts, this is when we detected the responder monitor state changing from green to red. Okay, so the monitor just went to red. That starts the clock right here. So at T1, the responder realizes that it's red, and so it looks at its sequence steps to try to fix it. Maybe it'll try one of those responders, again, restarting the app pool or restarting IIS to try to fix it. If that doesn't fix the problem, in other words, if the monitor state stays at red, 10 seconds later, depending on the pipeline component that we're talking about, it's going to try another activity. Maybe in this case, it will try one of these other responders, fail the databases over, or bug check the server, or take the server offline because there's just no way to get it back into a production operation use. If the monitor state still stays red at that point, then it's going to go to its last time interval, T3, in which case things are unfixable in code. It's up to the escalate responder to notify the administrator through an event log that something needs to be fixed. And that something will be listed in the event log as well. So generally, as long as that monitor state stays red, managed availability will keep doing its things all the way to escalating to human. Anytime after one of the responders is finished, we look at the monitor states. If the monitor states go to green, there's no further action for us to do at that point, and we will stop the process and go back into just the monitoring mode since we don't need to recover anything at that point. Now, it's also tuned in the cloud. So a lot of the learnings that we're getting from running managed availability in Office 365, they will make their way into the on-premises product. And in fact, there are some changes coming in Cumulative Update 2, which is the next update we plan to release for Exchange 2013, where we have done some work to throttle some of the responders. And I'll show you what I mean by that in a minute. But it's all about us sort of cutting our teeth in the cloud first so you don't have to. And one of the, I think, more powerful aspects of managed availability is the fact that each of these probes and monitors and responders were created by the Exchange component teams. So again, using OA as an example, all of that stuff was created by the OA team. So managed availability is really just an internal framework that we made all the other Exchange component teams code against for monitoring, internal monitoring purposes. And so when you think about it like that, you know that whatever recovery action is taken is going to be the best possible recovery action because it was the component team who wrote that component that determined what would be the best recovery action. They know how to fix their component. They know what their component is in terms of healthy or unhealthy, why it might not be healthy, how to get it back into a healthy state, and so forth. And anything that we cannot fix automatically will get escalated to an administrator. And those are the kinds of things that we track in the service regularly. Any escalations that come to us where it requires, again, an operator to get involved, those are the kind of things that go back to that component team and we say, hey, we got into this scenario that isn't covered by your recovery actions. Why don't you think about how you could correct this scenario for us automatically in the future? And then sure enough, later on there will be a code change, and next thing you know, that scenario will be covered as well. So it's this brilliant feedback loop that we have where the system is telling us about things it can't do, and then we, of course, go and fix it for them, but now we have the ability to teach the system to do more things and reduce our burden even further. So responder throttling, there is responder throttling, and what we mean by that is there will be some scenarios there, depending on a combination of failures, if you will, where the responders are throttled both across servers and across a DAG, for instance, and throttled in time as well. Everything is sequenced in such a way that if certain things don't happen, we may skip doing a responder. And that's just something that we do because we recognize that there's no point in doing that future responder because we didn't get past step A in the first place. So there are some scenarios where the responders may wait before they invoke another responder, or depending on some of the responders, they may be skipped entirely. So for instance, if we failed over databases and that was successful, that we don't need to run the bug check responder because that would be effectively doing the same thing. So it's those kinds of things that we would do. So it really depends on the responder itself and the nature of the failure that needs to be corrected. Now, in Cumulative Update 2, we are introducing responder throttling across the board, and this will change the behavior of Exchange considerably. If you were running CU1, which is the build I'm running here, I could do that stop the replication service demo all day, every day, and it would work fine every single time. Because it doesn't matter how many times that service is stopped in CU1, the managed availability responder will automatically restart it every single time. In CU2, that will not be the case. In CU2, there will be limits per day to the number of restarts that a responder will be able to do. So if I were running CU2 code, I might only get 2 demos each day out of that, because after the second restart, the responder throttling is going to kick in, and it's going to say, well, we've restarted this service twice in a 24-hour period, so there's something more serious going on. We're not going to restart it again. We're going to fail over instead. And you'll see that if whenever we throttle a responder, you'll see that in event 501, it will say responder activity unsuccessful due to throttling, and you'll know that that's why the restart didn't happen automatically. So I'm not going to go through every single thing on here, but I just wanted to point out this will be the new throttling that we'll have in CU2. Yes?
There seems to be a lot of learned behavior.
Yes.
So what happens to that learned behavior if one of the servers gets reinstalled, or if you add an additional server to the set?
So the learned behavior is static that exists in our code. It's not learning as it goes. It already has a finite set of knowledge. And that finite set of knowledge goes on the box every time you install Exchange. So it's built in. It's, in fact, you won't even really see a lot of stuff because it's all programmatic. About the most surfacing of what it's actually doing is through the event log that I showed you. Because all that stuff is just happening in the background, behind the scenes. And if you miss that stuff, you can always stop and restart the host service for it. And that will relog everything in that event log for you, so you can see all it's doing. As we introduce cumulative updates, there will be changes which could represent new learnings. But as the system is running, it's not learning new things and how to adjust to new things. It only has this pre-programmed set of steps that it can do.
But it is favoring certain servers because, historically speaking, they have been successful.
Is it favoring certain servers? No, it doesn't really know. It doesn't track a history of server health. It's only evaluating at that given time. So, for instance, if you had a server that was always, super healthy, never had a problem with it, it is possible that when managed availability goes to evaluate it, that maybe there is a new problem with it that will get discovered and fixed then. So, history has really no bearing on what managed availability does, other than it does know what responders it's already invoked, so it knows to go to the next one in the sequence, and it knows which ones need to be throttled. But otherwise, the historical aspects, every failure is unique and treated as its own single case, and that's actually another significant difference now that I think about it. We don't do any cause or there's no correlation going on like we used to try to do. We largely don't really even care about trying to do that stuff anymore. As I said earlier, it doesn't really matter, if you want to keep tabs on your services, go ahead. But what you're really responsible for now is delivering a good user experience. And so that's really what we're going for with managed availability. All right. So the management services, those are the health groups. The health groups are health sets. The way we have it reported is we take those 4 different customer touch points, the user and the system touch points, and we report them into System Center Operations Manager. We do also report them through the management shell. And in fact, if I were just to go over here and show you one of the commands, for example, you'll start to see why using something like System Center would be preferable, because I could do something like get health report, which is the primary managed availability commandlet that you would use. And I'm just going to say server is going to be EX1. And if I don't say anything else, it's going to give me a health report for every single managed availability health set that's on here. So I'm going to let this list go for a second. So if we zoom up and we look at this list, you can see here all this long list of stuff in this column right here. These are all the names of the health sets that we have in managed availability, and there's just dozens and dozens and dozens of them. And within each one of these health sets are the probes and monitors, and responders. And you can see, for example, if you look up at the top where it says data protection, not quite at the top, but sort of a third of the way down, it says data protection, and then over there it says unhealthy. It's unhealthy because the replication service is part of that health set. And on my server, EX1, the replication service is not only stopped, but it's disabled. So managed availability can't restart it. So that health set, that data protection health set on EX1 is going to remain in an unhealthy state until an administrator comes and frees up that service and starts it back up again. But as you might imagine, this is kind of a long list, and it gets even longer if you start looking at the probes and the monitors and so forth. And so using System Center Operations Manager, we give you this nice graphical display that you can double-click and drill into and so forth. And I would encourage you to download this deck, because in the hidden appendix of this slide deck, I have screenshots of what it looks like in System Center, so you can see the experience that you get with that as well. But there's just a ton of information that you can get from managed availability, but a lot of it requires you to know a lot of the shell commandlets. And so I'm going to be talking about some of those in the high availability session as well. Okay, so now in terms of the health sets, so the health sets, this is very similar to that customer touchpoint slide we saw before with those 4 levels of probes. The health sets, as you can see, OWA has 4 types of health sets. Again, using OWA as an example. This is just like the other slide that you saw, except it doesn't have those numbers on it. So the customer touchpoint health set for OWA would include the proxy health set for the OWA.proxy and the protocol health set for OWA.protocol. Okay, and you'll see a lot of similar naming going on for the other protocols, like Active Sync Proxy, Active Sync Protocol, POP Proxy, POP Protocol, et cetera, et cetera. You'll recognize a fairly standard naming scheme. And these health sets, as I mentioned before, they will be evaluated by whatever component is the worst in the health set. So again, the replication service was stopped, so that made my whole data protection health set unhealthy. And in fact, I could drill into that. I could see just that health set if I wanted to. So using the same command, I'm just going to pass the health set parameter, and I'm going to say data protection, because I know that's the health set that includes replication and the DAG and so forth. So I can see at a glance, just looking at this one, that it's in an unhealthy state. And again, come to the tips and tricks session, and I'll show you guys how to drill down into that and find out why it's unhealthy or why things restarted and so forth. All right. Okay, so here's those 4 numbers again, so you can see how they map to the customer touch points. So again, some of those are infrequent, lightweight tests. Others are going to be very deep tests and so forth, where we check the entire stack. And this is going on all the time, constantly in Exchange. As long as your servers are running, Exchange is evaluating things and making sure life is good from all component perspectives. Now, using the command line, get server health and get help report are the two primary commandlets that you will use. Get health report is going to be better for you because it does everything that get server health does as well. And this is actually an improvement to the experience. In the RTM version of Exchange 2013, we used to have to run get server health first and then pipe the results to get health report. Now, starting with CE1, get health report now does all the same RPCs that get server health used to do. And so now you can just use get health report, as you saw me just do, to get details about the managed availability health sets and their health and whatnot. So here, the third commandlet that we haven't talked about is this get monitoring item identity. And that commandlet is there so that you can manipulate literally the monitoring items themselves. So we're looking, for instance, at the OA.protocol monitoring item. And you can see, for instance, for each one of these monitors, we have a couple probes up there, we've got a couple monitors, and then we've got several responders that are associated with that as well. And this is how you can see what's in an entire health set. You can use the get monitoring item identity commandlet to basically interrogate an entire health set, figure out the probes that are in there, figure out the monitors and responders that are in there, and then you can dig through the event log, as I mentioned earlier, to get the actual details on each one of those components. Now, there are overrides. You cannot manipulate everything, but you can sort of turn things on and off, if you will. So for example, a more common override is doing what we call putting a server into maintenance mode. So maintenance mode is basically where you take a server and you turn off the managed availability responders. So managed availability is still there, it's still operating, it's still evaluating, but it's not taking corrective action. Okay? When would you want to do something like that? Well, anytime you're going to do patches to a server or install a cumulative update or do maintenance on a DAG member or anything like that, you will put the server into maintenance mode, basically turn off the automatic self-recovery features of managed availability so that it doesn't interfere with whatever you're doing. And then when you're done with whatever maintenance you do on the server, then you take the server out of maintenance mode and put it back into production. Okay, and it's kind of an easy thing to do, and there's instructions on TechEd for that. The overrides, there's two forms of overrides. One is a server-level override, and the other is a global-level override. Server-level overrides are obviously on a per-server basis. It's your way of saying, I'm doing something special with this server. I need to override what managed availability is doing. I'm going to turn off some of these components, if you will. More common example is I've just finished installing Exchange, but it's not configured and ready to go into production. Then I might go ahead and do a server override on that server until I'm done configuring it. A global override would be when you just need to handle the entire environment. So global overrides are stored in Active Directory. Server overrides end up getting stored on the registry of the server on which you create them. But a global override will apply to all the servers that you specify, and that will override things on a global nature. So if you had, for instance, you're rolling out some Exchange integrated application, and you want to make sure that managed availability doesn't do things as maybe services are being stopped and started, you might invoke a temporary global override and stop managed availability from doing certain things while you're working on that server or sets of servers. We don't allow you to use wildcards, unfortunately, so if you did want to do an override of everything that is comprised within a health set, unfortunately, you need to do that one by one by one. There is no wildcarding yet. Hopefully that will come one day, but we don't have it today. Now, in terms of the overrides, you can view overrides that have been set using either the get server monitoring override or get global monitoring override. You can create overrides. Again, here's the syntax for a server or a global one, and you can remove them as well. And again, in the appendix, I have all the different properties names as well, but you can also get them from the management shell if you need to later on. those overrides do not take effect immediately. In some cases, it could take anywhere from 15 minutes to an hour for them to take effect, particularly the global ones, which will be dependent on Active Directory replication in your environment as well. You can, of course, force them to take effect earlier by stopping and restarting the host service for managed availability, but typically most customers won't need to do that, but you have that ability if you choose. And then in terms of the System Center portal, again, System Center is not required, but it will provide you with that premium experience, that quick at-a-glance view into the health sets for all of your Exchange servers. So you could do what I did and drill into that stuff through the management shell, line by line, command by command. Or if you're using System Center and you have the Exchange 2013 management pack, then it will know about our health sets in Exchange 2013, and it'll create user interfaces that you can double-click and drill into all your health sets that way. It is a much, much better experience. But in the absence of that, again, any event log collection tool can act as the escalation engine for that. There are 3 dashboards that we have for you in System Center. One is the active alerts. So any escalations from managed availability that can't be auto-corrected, that would be an active alert. So that would be where an administrator would likely spend most of their time waiting for some alert to come in. And then there's the organizational health, which is showing you all the health sets across your entire org, and the server health, which shows you the health sets on a per server basis. And again, just like we do in the shell, the overall health of the health sets will be reported based on the least healthy component. So if you were looking at the server health on EX1, for instance, you would see that the data protection health set is also in an unhealthy state, again, because that service is not running. We support management packs for both 2007 R2 and SCOM 2012 as well. System Center 2012 will give you a better experience, obviously. All right, here's what some of the stuff looks like. You can see up here we're looking at the server health, and we've double-clicked it and looked into the view. So let me zoom up in here for that so you can see a little bit better. So just looking up at the top here, you can see there's our server name, and you can see this was an old build of Exchange. It's running the client access server role, and at a glance, we can see it's critical. And if we double-click critical, then we get this whole state view table that you see here, and that exposes each of the individual components for that particular health set. So you can see it's calendaring is fine, remote PowerShell's fine, ECP is fine, web services all good, Outlook, auto discover, all good, but boom, you get to active sync, and active sync is marked critical. And because active sync right now is having some sort of problem and is in a critical state, that means that the health set for the entire server for this health set is going to be in a critical state as well. Okay, it doesn't mean that the server is really, really bad. It's, again, just one thing that's bad, but that's how we display the state and status of things. That's how we express health. If anything is unhealthy, we consider the whole health set unhealthy. If everything is good, we consider the whole health set as good. All right. So again, just reiterating the bottom line, getting back to those synthetic transactions, managed availability is like the digital user with administrative capabilities inside every Exchange server. And it's sitting there doing things just like a user would, sending mail, detecting failure, recovering from the failure in some cases, detecting that the restart was completed, verifying that things are healthy, and then repeating that process over and over again, trying to find problems and trying to fix them as it finds them. So the whole idea around this is we know that stuff's going to break, but we don't want the experience to. That's really what it comes down to. Stuff breaks and the experience does not. All right. So, any questions? I know we've got about 2 minutes left for questions. Did you like that little flying bird there? If you like that, it's even more fun to watch backwards. Okay. All right. Yes, sir. Yes, yeah. Yeah, in tips and tricks, what I'm going to do is we're going to take a scenario and walk backwards from it. Like, oh, something happened last night. Let's figure out what. And I'm going to walk you through how you would do that investigation. But you said the state was inactive. So is that RTM or CU1? Hmm.
It felt like I was stuck because there was no accessible user interface. With 2010, I probably would restart the service.
Yeah, if you want to send me details on that offline, there's my email address. I'd be happy to look at that for you. I wouldn't expect any of those to be in an inactive state. That sounds like maybe something hung on startup or instantiation or something. Okay, sure. All right, anything else? Probably got time for one more question. All right. Well, thank you very much for coming. Hope to see you at the high availability and tips and tricks. And of course, there's other great exchange sessions, including one on the client access server role happening in this room after this session as well. Thanks very much and enjoy the rest of TechEd.